Hello, my name is David Wright and I'm a software instructor for Cray Research. I cover the subject of accounting, performance evaluation, capacity planning, and NQS internals and troubleshooting. The following video segment that you're about to view will explain the new features of NQS in UNICOS7 Updates. You should now turn to page 1 of the NQS section of your workbook that will be referenced in this video segment. There are two principal enhancements to NQS in UNICOS7 Updates. First, NQS can use fair share data to select batch requests for execution. This makes it possible for share to influence both queued and running requests. The amount of influence that share has on NQS request scheduling is established by NQS scheduling parameters. Second, the file transfer agent or FTA network product can now be used to handle the spooling of users' standard out and standard error to remote destinations. Bear in mind that UNICOS 6.0 and 6.1 NQS databases are not compatible with UNICOS 7.0 databases. This is because of changes made to support FTA and NQS fair share. And due to differences in the UNICOS restart files, UNICOS 6.0 checkpoint files cannot be restarted from, and all NQS requests should be finished before starting NQS 7.0. The introduction of the NQS fair share feature impacts the Intra queue priority and the queue sub command. The Intra queue priority determines the order in which requests in a queue are initiated and the order in which requests are displayed by the QStat command. The fair share NQS scheduler uses a special algorithm to select a request for initiation from all of the eligible requests in a specific queue. The order in which queues are considered does not change. Only the order in which requests are selected from a queue changes. The eligible request with the highest intra-queue priority is selected next for initiation. Eligible means that it meets all quotas such as run limit, user limit, and group limit. The intra-queue priority algorithm is as follows. First of all, the time in queue divided by the max time in queue is multiplied by the time waiting factor and a 1 added, minus the requested CPU time divided by the max requested CPU time multiplied by the CPU waiting factor, minus the requested memory divided by max requested memory multiplied by the memory waiting factor, plus the share pri divided by the maximum share priority multiplied by the shared waiting factor. This is all divided by the sum total of all waiting factors. The following parameters determine the amount of influence of the associated values on the computation of the intra-queue priority. The fair share usage, the time in queue, the total requested CPU time, the total requested memory values. When all parameters are set to the same value, all of the waiting factors have an equal effect. The requested CPU and requested memory values are the per request CPU and memory limits from the batch request. The max time in queue, max requested CPU, and max requested memory values are from the maximum value requested of all requests in the queue when the initial scan of the queue is performed to determine how many requests meet the quota limits. The fair share usage value is obtained by accessing the LNode information through a limits call if the user is active at the time. Otherwise, the UDB is used. To set the waiting factors that determine the intra-queue priority for runnable requests, use the following queue manager commands. Set sched factor share, which sets a waiting factor for fair share priority. Set sched factor CPU, which sets a waiting factor based upon the per process CPU limit requested. Set sched factor memory, which sets a waiting factor based upon the per process memory limit requested, and set sched factor time, which sets a waiting factor using the time the request has been waiting in the queue for initiation. To display the waiting factors, use the show parameters queue manager command. Keep in mind that the waiting factors are only significant in relationship to each other. If all waiting factors are 0, the request is selected from a specific queue on a first in, first out basis. In the sample output shown on page 7, the fair share priority carries 4 times the weight of the other values. Because of the creation of the fair share NQS, the QSub command behaves somewhat differently from the previous releases. First, the -P option of the QSub command can no longer be used to establish the intra-queue priority for a batch request. This is only done by the waiting algorithm instead. In addition, requests using QSub now use the user's currently active account ID when the batch request is initiated by NQS. Furthermore, the QSub-LF command behaves differently. This command sets the per process file limit. Prior to UNICOS 7.0, there was a discrepancy between the documentation of this form of the command and the actual implementation of the command. The documentation describes the per process file limit as the total number of file system blocks consumed by that process. However, the pre-7.0 implementation set the file size limit to the process, not the file system accumulation of the process. For 7.0, the implementation of QSub-LF has been brought into agreement with the existing documentation. This change also ensures consistency with the implementation of the per request file limit. Note, because of this change, the QSub-LF command may produce a disk limit error. If so, the value specified by the LF option will need to be increased. Alternatively, the value of the pFilelim field in the UDB will need to be increased. The last feature of NQS 7.0 is a file transfer service, or FTS, supporting the NQS-RQS network protocols for both TCP/IP and Superlink. This service will let FTA control and manage the transfer of NQS output to remote hosts. NQS can be configured to use various methods to return the standard error and standard output files of a completed request to a remote host. Use the QManager command add output agent to indicate which method to use to return these files to a specific host or machine ID. There are two output agents. You can specify one or a combination of them. NQS is the default output agent. The NQS net client tries to connect directly to the remote host and transfer the files. If errors occur, the output is returned to the user's home directory on the machine of execution. If FTA is configured, NQS passes control of the output file transfer to the UNICOS file transfer agent. If errors occur, FTA either saves the transfer request or tries to transfer it again, or returns the output to the user's home directory on the machine of execution. Commands for adding and deleting output agents are add output agent and delete output agent. Alternatively, you can also specify an agent on the add MID command. To display output agents, use the show MID command. The output agents are shown in the agents column. I would like to finish this module by advertising our NQS internals and troubleshooting course. This course is designed for analysts and system support staff that have to troubleshoot NQS problems. It is a 2-day course that covers the mainline logic flow of an NQS request and the packet protocol to get the request across the network and running. Reading of the NQS log is the primary skill this course addresses. This course is taught by software instructors from the Cray Research Corporate Training Center. Contact your regional training coordinator for details on the next NQS class. This ends the NQS 7.0 features module of the UNICOS 7.0 update video. If you have any questions, please contact me at daw@tngstar.cray.com or by calling Cray Research at 1-800-BUG-CRAY and ask for David Wright. Hello, my name is David Wright and I'm a software instructor for Cray Research. I cover the subjects of accounting, performance evaluation, capacity planning, and NQS internals and troubleshooting. The following video segment that you're about to view will explain the binary support of the accounting system billing algorithm. You should now turn to page 2 of the accounting section of your workbook that will be referenced in this video segment. The following enhancements have taken place for the accounting package. First, configurable parameters are located in the itsy-config ac_config. Parameters such as SBUs can be modified without recompiling the accounting code. Number 2, code has been added to allow the system billing unit or SBU calculations to be changed by sites without source licenses. Some sites have made local modifications to the accounting source, such as different report formats, additional types of accounting information, etc. At this time, local changes to code other than SBU calculations are not supported by the release. Sites requiring such modifications will need source code. Number 3, the TAC data files, which are created by the standard Unix accounting programs, can be converted to CAC format. This lets the TAC data files be processed by CSA. The ACT to CSA command performs the conversion. Number 4, a change has been made as to how the holidays file is handled. This file contains the prime and non-prime timetable for the accounting system. Sites can modify this file to reflect the local holiday schedule. In the past, the holidays file was automatically overwritten each time accounting commands are reinstalled using the nmake file. With this release, the file userlibac holidays is only written if it does not already exist, therefore minimizing the likelihood of overwriting site-specific changes. Number 5, the structure of the accounting source directories has been changed. Where possible, the source code of the same command for all Cray computer systems has been merged into the same file. Number 6, a new front-end formatter template has been added. The CSA FEF2 command summarizes session file records and outputs them in ASCII format. This command is not intended to be run in its distributed state. Rather, it is meant to be modified by sites that have UNICOS source code. The front-end formatters, CSA FEF, CSA FEF2, and CSA IBM, can only be modified by sites that have UNICOS source code. On page 5 of the accounting module, you will find the Spu algorithm. The algorithm is composed of 4 parts. First, the prime time, CPU, memory, and I/O resources used. Second, the non-prime resources used. Third, some miscellaneous charges, such as tape I/O, terminal connection time, station transfers, SDS use, and device accounting. And fourth, the NQS weighting factor. Sites should set the prime and non-prime components the same. If not, a process that is swapped during prime time due to a small NSCHED-V-H option will still be charged the prime time rate. Instead, most sites have a night NQS queue that will adjust the bill favorably. If the night queue NQS weighting factor is 0.5, this will cut the bill in half. In the example on page 4, it was decided to charge $100 per hour CPU time. Since CPU time is in seconds, this is 100 divided by 3600, or $0.027 per second. So P underscore time is 1, and P underscore X time is 0.027. The example also charges $25 per hour of locked I/O wait time, or $0.000406901 for P underscore IMEM. The memory charges are $25 per megaword for each hour of CPU time, and $50 per hour for each megaword of locked I/O wait time. This works out to be $0.0004 for P underscore XMEM and $0.0008 for P underscore IMEM. For I/O, the example charges for bytes transferred by the process based upon what charge is needed to recoup the cost of the drive. This turns out to be $0.0003936 for P underscore byte I/O and $0.00001 for P underscore I/O. And to discourage logical I/O requests, the example charges 1 for P underscore log I/O. Because of cache hit rates, most sites do not charge for physical I/O, or the bill would not be repeatable and would cost more on a cache I/O loaded system. Following is a list of the accounting configuration file ACK underscore config. Inside the menu system, you can access a copy of this file. Some sites charge for interactive connect time that comes through TCP connections such as Telnet, RLogin, or FTP. Set the SBU prime and non-prime fields to that cost, such as $0.001 per second. Next is device accounting. At some sites, this is used to recoup the costs of a dedicated drive. That site would then use the devac command to label the device as to its type and come up with a charge to recoup the cost. Most sites that use device accounting, however, use it for performance troubleshooting and capacity planning. For this type of site, the SPU is left as 0 and the file system's name is used in the device name. This name will then appear in JA, ACCOM, and CSAC rep reports. It is useful to find an application that is running in a particular file system and due to a heavy I/O or LD cache load. Warning, device accounting turned on will likely double the size of the PAC file. Character devices are usually not used, and the names and position in this table is not to be changed. To encourage multitasking, some sites will give price breaks for multitask processes that get good multitasking efficiency. These weighting factors are usually set up as 1, 1, 0.9, 0.9, 0.8, 0.8, etc. This will then give a price break on CPU time. The NQS SPUs are set up for each NQS node on your network and for each queue. The next section is the prime time SPU setup as we explained in the earlier example. The SDS charges are defined next. Also explained earlier, the non-prime charges should be set identical for prime charges, or processes that run over the prime-non-prime boundary will be incorrectly charged. If the site wishes to charge for tape I/O or operator mounts, see page 13 to set that up. For station transfers, you need to set up the charges for each station you have on your network and what the station ID is. You can then charge for blocks moved between the station and UNICOS. On page 15, we can set up some of the specifics of the accounting system, such as the file system that the accounting data is in, the path for the holidays file to use, and mail list for errors in accounting being shut off types of messages. For the memory integral, most sites use MEMINT2, which charges for wall clock CPU memory integral. Also set up here is the minimum number of blocks before accounting can run or the accounting system is shut off. Finally is the number of holidays. I'd like to finish this module by advertising our Accounting Internals and Troubleshooting course. This course is designed for analysts and system support staff that have to set up and troubleshoot accounting problems. It is a 2.5-day course covering all aspects of CRA accounting. The course is taught by software instructors from the CRA Research Corporate Training Center. Contact your regional training coordinator for details on the next UACC class. This ends the Accounting 7.0 features module of the UNICOS7 Update video. If you have any questions, please contact me at daw@tngstar.cra.com or by calling CRA Research at 1-800-BUG-CRA and ask for David Wright.
Hello, I am Stacy Heinrich and I'm a software instructor for CRA Research. I specialize in the Input-Output Subsystem, or IOS. For the past 2 years, I have been working exclusively on the iOS Model E. I have developed the software training classes on iOS E. I have also written a large portion of the material included in the iOS E manuals. The following video segment summarizes the iOS changes that are coming along with 7.0 UNICOS. Please turn now to the iOS portion of the 7.0 Update Workbook. As indicated on page 2, UNICOS 7.0 supports all models of iOS hardware. Use the iOS 7.0 software release if you have a Model B, C, or D iOS. Use the iOS E 3.0 software release if you have a Model E iOS. Page 3 lists the changes for the iOS Models B, C, and D software. This is very mature software, so the new release primarily provides added resiliency and maintainability features. Notice the iOS High Performance Parallel Interface, or HIPI, channel software includes some internal changes that allow it to run faster and more efficiently. Another change in the new release attempts to make the best possible use of the limited amount of local memory in an IOP. Local memory reserved in the Master I/O Processor, or MIOP, for expander devices is released on systems that have an OWS operator workstation. Verification code now included in the iOS operating system attempts to maintain the integrity of IOP operations. For example, there are checks that try to keep the local free memory chain from being corrupted. Debugging aids are provided in the form of a new command and additional information to assist in problem dump analysis. The punt command is added to simplify the process of dumping the iOS when the MIOP is unresponsive to console input. The command is typically typed at the console or in the console window on an IOP other than the MIOP. The punt command forces the IOP to punt, that is, halt. This generally puts the MIOP into system dump processing, and a dump is captured for analysis. The history trace in each IOP now includes parameters that are commonly very helpful in dump analysis. Additionally, I/O request packets are left unchanged after they are processed by the IOP. This can provide clues to what was happening in the system before a halt occurred. ASCII character strings are added to mark kernel data structures, thus making the structures easy to find quickly when doing dump analysis. Page 4 lists the changes to iOS Model E software. The 3.0 release that comes out with UNICOS 7.0 includes new hardware support, new features, and bug fixes. Some miscellaneous details about the release are given in the second paragraph on page 4. You can read that now. Before I talk about the items in the release, I will point out the supporting documents that contain additional detail. They are listed toward the bottom of page 4. The first document, RN 5045 3.0, is the release and installation notes. This is the only document that comes to your site in the release package. The document contains useful information such as the following: basic iOS E hardware and software descriptions. Hardware supported by this release, including Cray Research mainframe types and peripheral devices. A comparison of the iOS E to other models of iOS. More detail on the items I'm presenting in this video. Descriptions of the software training classes. the binary release support policy for iOS-E, an evaluation of the software including performance test results, licensing and ordering information, a description of what is included on the release medium, which is compact disc, or upon request, streamer tape, and finally, instructions on how to install iOS-E 3.0 software. Again, those items are all included in the release and installation notes, publication RN 5045 3.0. The second document, SD2107, is the iOS-E guide. This is a CRAE private document. This means that non-CRAE employees can obtain a copy of this manual only with the approval of the appropriate CRAE manager. The iOS-E guide is intended to provide information to a person who wants to know what the iOS-E is like, but who does not need to know enough to be able to resolve an iOS-E dump. Some of the information in the release and installation notes was derived from the iOS-E guide. However, the guide presents a level of detail beyond that found in the release and installation notes. The iOS-E guide, SD2107 3.0, contains chapters on the following subjects: hardware, including architecture, channel adapters, and devices supported; software, including architecture, configuration, and devices supported; system dead start, including diagrams; diagnostic tools to assist in problem resolution; and dumps, specifically what to do when the iOS-E halts or hangs. Again, those items are all included in the iOS-E guide, publication SD2107 3.0. The third document, SP2108, is the iOS-E Internal Reference Manual. This is a CRAE proprietary document. This means that non-CRAE employees can obtain a copy of this manual only with the approval of the appropriate CRAE Vice President after a non-disclosure agreement is signed. The Internal Reference Manual is intended to provide information to someone who maintains iOS-E software at the source code level. This manual provides detailed explanations and some diagrams of the way parts of the iOS-E software work. The Introduction chapter presents information that is common to all areas of the iOS-E software, while the rest of the chapters cover the monitor and each of the peripheral support areas, such as disks and tapes. The manual describes all packets that pass between the iOS-E and UNICOS. The manual also covers things like how each device type uses the channel buffer when doing I/O, and the data structures maintained by each software entity. Now that I have considered the iOS-E documentation, I will describe some of the changes in iOS-E 3.0 software. As I go through this, please remember that the iOS-E 3.0 software is a binary-only release. The support policy for iOS-E is very different than traditional iOS support. Field employees in general are looking less at iOS-E dumps, and the problems are resolved more by software product support and software development. The expectation of a field employee is that when an iOS-E problem arises on site, pertinent information is saved. This includes error log files, system activity log files, system dumps, and so on. The field employee then need only perform a simple initial analysis on the dump using tools running on the OWS-E before contacting the appropriate support center. With this in mind, what I have gathered for you and present in this tape are things that you would most directly have to interact with. I have not included all internal changes in this update summary. Page 5 begins with new device support. Because the IOSE disk software design implements a generalized disk subsystem and specialized disk drivers, the IOSE changes for new disk devices are localized to the software drivers. DD42 and DD62 disk drives are now supported by changes made to the respective drivers. DD4R devices are supported by the DD40 software in the IOSE. Helical scan tapes are supported by the IOSE's device-independent IPI 3/IPI software subsystem. The next topic on page 5 is one of the new man pages. There is now a man page called halt codes residing on the OWSE. Enter man halt codes, add an OWSE prompt, and you get a listing of the IOSE halt codes and their meanings. This can be especially helpful if your IOSE has halted. Another new man page for troubleshooting the IOSE is available in this release. It is called TRB Shoot and is written Troubleshooting Guide to Aid in Problem Analysis. This informational man page gives you a list of what to save when you experience problems with your computer system. In addition, the man page provides hints and clues on how to do initial problem analysis. You can then call your support center and report the halt code, the program module that seems to have the problem, and other information you have determined by following the steps in the troubleshooting man page. A useful feature in this release is the history trace formatting filters to use in conjunction with eCrash. eCrash is a tool very similar to Crash that runs on the OWSE. The purpose of eCrash is to look at Model E iOS dumps, much like Crash allows you to look at UNICOS dumps. The ETF at the beginning of each filter name stands for IOSE Trace Formatter. The rest of the name of each filter indicates what traces it formats: BlockMux tapes, communications devices, and so on. These filters come to you on the IOSE software release media. They are installed in the bin directory of user CRI on your OWSE when you follow the software installation instructions given in the release and installation notes. Man pages are included in the release. Use the man pages to get information that enables you to use the trace filters. Fundamentally, to use them, you get into the eCrash tool. In eCrash, you ask for the trace entries, and you pipe them through one of these trace filters. The filters do some formatting of the trace entries for you. All the history trace parameters are not identified, but the trace event is translated from a number to some ASCII characters. This trace event indicates, for example, if a packet has just arrived, a read request is being processed, or so on. Again, these history trace filters and eCrash are documented online with man pages. They are also included in the SR 3077 OWSE reference manual. Page 6 lists the IOSE software monitors. This set of tools is intended for problem analysis, not system performance. Running these monitors continuously with the intent of monitoring IOSE performance may cause some performance degradation. Some of the monitors were available in IOSE 2.0, and some are new with 3.0. The E at the start of each name distinguishes the tools as iOS Model E tools. The MON at the end of each name stands for monitor. The rest of the name of each monitor indicates what software it monitors. BMX for BlockMux tapes, COM for low-speed communications or network, and so on. These monitors also come to you on the IOSE software release media. They are installed in the bin directory of user CRI on your OWSE when you follow the software installation instructions given in the release and installation notes. Man pages are included in the release. Use the man pages to get information that enables you to use the monitors. The last item I want to mention is the new bootable binary files, eIOP.hpi and eIOP.comhippie. The eIOP and the names indicate the files are to be booted into eIOPs, not MUX IOPs. The comhippie file combines low-speed and high-speed communications, or network, support. The HPI file supports IPI3 protocol devices running on on Hippie hardware channels. The comhippie binary file allows you to put low-speed networking devices and high-speed networking devices on the same I/O processor. This is the only mix of channel adapters in an eIOP supported. However, you must note the restriction that you can have only 2 CCA1 channel adapters and 1 HCA3 and HCA4 channel pair on the eIOP running the comhippie software. Additional restrictions are listed in the release and installation notes. This concludes the summary of iOS changes for the UNICOS 7.0 software release.
Good day. I'm David E. Kale, and I'm going to talk on 2 topics today. In particular, those topics are online diagnostics. I'd like to just give you an update as to what's happening for online diagnostics, and SMART, the SMART system, which in a sense does the shrink wrap around some of the online diagnostics and gives an X-Window style and flavor for them. If you'll go to my transparency and handout set, I'd like to kind of talk you through some of the topics that I've covered there. First, if you look at page 2 of my handouts, you'll find that I have some files listed and some directories. These are the ones you need to know about as far as where the diagnostics and SMART reside. In particular, /CE for the customer engineer or CE login is where the scripts and binaries live. /CE/bin covers the executable binaries. /CE/scripts covers the scripts that control and issue these binaries. The most important script that you'll encounter is called run sequence. That script is commonly invoked by a chronological timer or cron tab from the CE login and executes the online diagnostic binaries. CE log is where log outputs go, oldmon for the offline diagnostics, and /CE/smart is where the smart package resides. In addition, if you have an iOS, you should have something like this. Taking a look at page 3 of the handout, just to point out what's in which directory in general, this is in /CE/bin. I've ordered these according to whether or not the diagnostics deal with the CPU, the online tape subsystem, the disks, the network, the iOS, and again, utilities you need to know about. Run sequence is in /CE/scripts. To invoke run sequence, a cron tab is issued through the system, usually through the CE's login. Sometimes the cron tab can be invoked through the root user login. The example I have here shows user spool cron tabs and the CE file. As you can see here, this cron tab does a check on a 4 CPU cray. One thing to point out, notice the minute sequencing 0, 15, 30, 45 for the online diagnostics. On an 8 CPU machine, this usually runs 0, 7, 15, 22, 30, 37, 45, 52, and cycles through again. I'm waiting for a 64 or a 4096 CPU machine to see what they're going to do with the online diagnostics. Another thing to point out, this is the default style that's supplied. One thing that you really do have that is negotiable between the customer and the Cray site analyst, Cray support staff, Cray CE, is when these run. This again is the supplied default example. Run sequence, which was a script that was invoked by that cron tab, is basically a shell script that has a series of environment variables, actually not environment variables, but locally defined variables built into it. The first section of the script contains these variables. I'd like to walk you through them because I think there are some important things to know about them, and just to remind you of what they are. Diag bin, CE bin, where the diagnostics are, the output log file, scripts, run log. The scripts are traditionally niced down 4 points on the nice factor. Console is turned on, output's going to go to /dev/console. Down CPU is off. Do you want to automatically down a CPU if it fails the test? Save core is off. This option is to save a core file if the diagnostic fails. Do a core dump, in a sense, of the diagnostic. And lastly, a mail list, basically a list of user IDs that should be warned if something happens. The next page here I have, page 6, lists off the example for run sequence and a text example for mail list. And along with the things on mail list, you can identify user IDs on other machines. So there's really no big change for online diagnostics for UNICOS 7.0. If you'll go back to your handouts, if you look at them, there really weren't any changes, but the important thing that you have for those diagnostics is that they're officially defined as asynchronously releasable. Be careful. They really aren't asynchronously releasable at this time. If you order UNICOS 7.0, order the online diagnostics set along with it. There have been some instances in the field. If you need to, you may have the information available on Crayamid that point out the fact that a new release of UNICOS was ordered. The diagnostics were considered asynchronously releasable, were not installed when UNICOS was installed. Consequently, error messages occurred and problems seemed to develop, and the difficulty wasn't a failure of the operating system or a failure of the Cray hardware, but actually an incompatibility between the release level of the diagnostic and the release level of the operating system. So a word of caution, when UNICOS 7.0 comes out, 7.x, order the online diagnostics with it. If you'll take a look again at my handouts, I'd like to pick one more topic to talk about, and that's basically SMART. Page 7 of the handout points to some information on SMART. What I did for the example that I'm going to show you is I went to my workstation on my desk and opened up a window, did a telnet command to a workstation in Chippewa Falls, and from that workstation then invoked SMART and dumped the display back down to my workstation. So what you have is a live example of frame by frame working through SMART. The example that I'm going to show you is SMART 2.0. There are some advantages with SMART 2.0. We'll see them as we go through this. If you look at my handout on page 8, I'd just like to highlight the time here is listed at 10:15 in the morning when I started this. I connected to MWS 2201. I sent the display back to my workstation, defined the display, and Sure enough, I typed in the wrong command, start smart instead of smart start. Changed to the CRI smart bin directory. Realized I was supposed to type in smart start. Did that. Got the output saying starting the smart system on the MWS. To prove to myself that this was working, I did basically a PS minus AUX command. You can see from the output here, CRI smart bin smart man is running, and CRI smart bin, etc. So smart is firing up and starting to execute. To invoke the X Windows display set for smart, once that's done, X smart, XSMARTE. Note the time, 10:17. The next frame was when the smart display came up. 10:22, 5 minutes later. Smart is really a shrink wrap around the already existing online diagnostics. The mission of Smart, just to remind you of it, is to provide three things. First, the shrink wrap around the online diagnostics. The second is the ability to do the X Windows display type operation. The third really is to invoke command capabilities to interpret the output of the diagnostics and do some artificial intelligence decision work. At this time, the artificial intelligence decision work package really isn't there, and what you have for Smart 2.0 is the shrink wrap around the online diagnostics. Example here for the display, you can see each has a display box identifying the product portion of the hardware that Smart will deal with, and there's a series of little dialog boxes or buttons to press to select an option. This example shows CPU and then the selection of options for the CPU. Lastly, notice there's a quit button that will list off and quit the Smart package. Okay. With that in mind, if you go to page 12 of my handout, I decided to click over just to fire up an inspection with Smart itself. And then from this one, I clicked the logs button to look at the logs output. All of this may display on your page. I'll slide it up in just a second. You can see I have Smart selected, the logs button pressed, and I get this type of an output. Note the default option if I issue an execute command request, and then what's going on, start date, end date, start time, end time for the time framing. What I did here was I clicked the execute button, and the output for this is here. So without having to know the /ce/logs directory name and the specific name and information on the logs, I can have some defaults built in. You can see from this logs -c smart -l info log -d, and then the display here, etc. Down the command line is automatically built in to execute. And then I have a snapshot of the log. I have a scroll bar for vertical scrolling through the log, and because the box is not wide enough, a scroll bar across the width of the log. To quit this, I would click the cancel button and the cancel button. I did that, and if you look at page 14 of the handout, I went over to the CPU this time and clicked the maintenance bar on CPU. Now, the interesting thing about this is when I clicked the maintenance bar, the mainframe was down. Smart 1.0 at this point would go poof, bomb, give me a core dump, and basically do some other ugly things and quit. Smart 2.0 at least is a little more robust. It comes out with an error frame that basically says it could not execute the command. And I think the interesting thing to point out here in the command sequence, if you look at this, could not execute the command. You can see user bin x11 xterm minus display automatically coming back to my workstation, minus E for execute CE bin OLDmon. So Smart, in essence, through the CPU and the logs button option, attempted to execute the command that you as a CE or as a site analyst would want to execute. This time, shrink wrapped around an xterm display. Well, since the Cray was down and not available, I decided to select a different option and take a look at it. And I went to the map bar, display the map, what's out there. I tried one more alternative I'd like to point out to you. I went over and clicked for the disk option for Smart. And if you look at the next one, went to the logs sequence. For the disk, I pressed the logs bar and got the disk window. Now understand, this is going to run the logs, not the Smart log, which is on the workstation, but the log on UNICOS. Okay, see what's going on. I went over and clicked the maintenance button, see if I could do something with just maintenance. And again, since UNICOS was down, this attempted to connect to the Cray, spent some time. If you look at the time gradient here, 10:31 was when I clicked the bar. And the response came back at 10:34. Disk request, maintenance option. I'll slide it up here so you can see again the error output could not execute. User bin x11 xterm. There's my display. Execute a shell command on the Cray to run DDMS. That's the basics for running Smart. As you can see, it's fundamentally a shrink wrap around the online diagnostic commands. One last thing, I decided to go ahead and quit Smart at this point. I did the quit button. It came up and said, confirmation, are you sure you want to exit Smart? I said, yes, I'm ready to quit, and terminated Smart at that point. That's the fundamental information around the online diagnostics and Smart at this point for UNICOS 7.0. The two things to remember for the online diagnostics and Smart are, number one, the online diagnostics, though they're defined as asynchronously releasable, you should be very careful and make sure that when you order UNICOS, also order the online diagnostic package at the same time. Match them. The second thing for Smart is that Smart exists is a current shrink wrap around the capability for displaying online diagnostics. It's a good package for, say, a site analyst to look at and to start working with without having to memorize all the commands. It also adds the fact that you have the ability to manipulate 2 or 3 windows with the X Windows style display. One final point I'd like to highlight with this, Smart 2.0 is not everything that's been advertised for Smart to date. There are some features and room for expansion yet. So Smart 2.0 is a lot more robust than Smart 1.0, but it's not everything that Smart's supposed to be yet. That's really the main things that I have for the online diagnostics and the Smart package.